everyone, Bella here, bringing you some mission rocket science from the launch pad. We're back sharing some of our free lesson plan, Feel the Heat. This is Feel the Heat rocket launch. Last time, we talked about endothermic and exothermic reactions. We even made some of those chemical reactions right in the Estes Education studio. So what does a chemical reaction have to do with a model rocket launch? The launch of a rocket depends on the creation of thrust that is great enough to overcome the weight of the rocket. Thrust is created when the propellant or fuel changes from a solid or liquid to a gas after it's exposed to an external heat source. This is called combustion, and it's an exothermic chemical reaction. During this reaction, the products are gases called exhaust. The gases push down out of the bottom of the rocket, and according to Newton's third law of motion, for every action there's an equal and opposite reaction. The rocket is pushed in the opposite direction. Most model rocket engines use a solid propellant composed of a fuel and an oxidizer pressed tightly into a solid cylinder of heavy cardboard. The fuel and oxidizer will not burn under normal temperatures. They must be exposed to heat. In this experiment, we want students to decide and describe the data they think they need to collect to show that a rocket launch is an exothermic reaction. They also need to create their own data table. We are going to use the IR thermometer to check and record the temperature of the engine inside the star hopper before launch. Then, after launch, we'll record the temperature again. We are using a half A3 4T engine today. We'll measure the temperature immediately upon recovery of the rocket. We don't want to lose any heat bringing the rocket back here to the table. Our temperature is 27.8 degrees Celsius. All right, let's light this candle. I already have our rocket prepped and ready to go. The range is closed. 5, 4, 3, 2, 1. Let's collect some data. We have 41.9 degrees Celsius. Let's take a look at our data. So we started with 27.8 degrees Celsius. After launch, it was 41.9 degrees Celsius. That's a difference of 14.1 degrees Celsius. That's a big difference. Our data confirms that an exothermic reaction has taken place. If you're unable to do a rocket launch for any reason, this lesson plan does include a presentation with sample temperature data you could use instead. I hope you now have a better understanding of how a model rocket engine can demonstrate thermal energy changes in a chemical reaction. Check the description for the link to the full lesson plan and all of our free resources. If you like this video, please like, subscribe, and hit the bell to be alerted for new content. Happy launching!